I have showed you how to do sequential circuit timing analysis by hand, and I showed you an example on how to correct it. Generally speaking, in the real world, especially if you're designing something on like larger circuits, something much more complicated than what I showed you, you would depend on a CAD tool, something similar to Vivado from Xilinx or Quartus in Intel. I will show you how Vivado generates all these different timing reports and how you can actually see the slack and the hold time and the setup time over there, and so that you can verify that your design is actually working as expected and it's not violating any of the timing constraints. This topic can get really complicated. What I'm about to show you is just the tip of the iceberg, and I'm just showing you something very, very general about the timing reports that Vivado generates. So let's get there. So in this project in here that I'm showing you, I picked up the asynchronous up counter that we covered when we talked about counters in there. And this is the type of circuit that only uses the clock for the first flip-flop, and then the other flip-flops do not have it. I'll show you how like the timing over there, like how you can actually read the timing constraints over there. And then I'm going to show you something much larger system, for example, in here. It's a system that we use in the next course, and it utilizes, as you can see, it's about 2,000 lookup tables and 1,700 flip-flops and something like that. So it's a lot more complicated. So I'm going to show you both systems. Anyway, let's get started with that, or let's see the smaller system. So just as just a quick reminder, this is how that system looks like. It's a bunch of flip-flops connected in cascade. The output of one flip-flop is connected to actually the input or the clock of the next flip-flop. And this flip-flop is connected to this clock of this flip-flop and this one and so forth. So it's an asynchronous counter. The actual system clock is only connected to this one. Usually you're going to see that all of the designs I covered in this class does not follow this. If you see a clock, it's actually connected everywhere, and you'll see now why in a second. So the first thing you're actually going to take a look at is, first of all, you're going to have to run at least up to the implementation. So you generate bitstream, or at least you run the implementation. And once you run the implementation, you're going to take a look at these diagram in here. So for example, or these reports, you're going to see something called design runs. And really the timing parameters are already here. So you can take a very quick look on it. You can get the utilization report that you used 5 lookup tables for flip-flops as we expected in here. But these are the timing parameters in here. So this is what we call the worst negative slack. This is actually the total negative slack, the worst hold slack, and the total hold slack. And then this is the pulse width slack, which we're not going to talk about. So what you really care about is in here is that the worst negative slack is actually, this is the setup time constraint. So you're looking for a number that is not negative in here. What this is telling me is I'm operating at 100 megahertz clock. That means it's 10 nanosecond. So this here, it's telling me that like within that 10 nanosecond, you have 9.1 nanosecond to work with. So you have a lot of slack in here. You have a lot of time. And the worst hold slack is telling me 0.219 here. So this is the first time you take a look at this. You just want to make sure that these numbers are not negative. If you want more information, usually you take a look at the report. So I'm going to do this, and I'm going to expand that menu. So the report in here, as it turns out, Vivado generates a lot of default reports. So it's generated already every single time you do the generate bitstream or the run synthesis. Actually, the implementation is what matters. You're going to see it. And there's a lot of them. For example, you might see a utilization place design or a utilization report. There's a lot of them. What we really care about for this purpose is actually the clock utilization in here. So this, or the timing summary, sorry, not the clock utilization. We only have one clock. So we need the timing summary. So we double click in here and it'll throw the book at you. There's actually this big, large document that actually gives you all sorts of information in here in a textual format if this is actually something that you care about. So for example, we can see the worst negative slack in here, the total negative slack, and so forth. But Vivado generates these reports by default, and you can take a look at them like on your own. For, let's see, the clock utilization report, what does it give me? It tells me clocking is a really complicated topic, and you have to use that clock so that you get to use the tree on that system. And there's actually a lot of clocking resources on Vivado, and you can not Vivado, actually it's Xilinx. So you can Google Artix timing resources, and you get a big document that tells you everything about timing in terms of that. In terms of like the Artix, the one we're using Artix 7. And you get to see the other ones, like how many of them you're using and so forth. Anyway, this is one way to take a look at it. So the design run is one way. The default reports that we generated is another way. And what you can do is actually, when you open the implementation, you can say open implemented design. And you can see this here, that's fine. And this usually gives you the placing and routing and everything that happens. So for example, my system looks something here, and like it shows you like this is the FPGA itself, and if you really zoom in, you will see the different lookup tables and what they have in them and how they're connected, and you can play around with this. What I would care about, at least for now, is actually what's happening in here. So you get a few things that, like whenever you open the implemented design here, you will see a few things. So the first thing here, I'm looking at the timing. So I get the same exact information, the worst negative slack in here, the worst hold. You see setup and hold, and the pulse width. What we care about is the setup and the hold, and you get to see all of them. Usually, I think in a couple of projects I work with, I've seen these in red. That means I've done something wrong, and then I had to correct for it. In most, if not all, the designs I shared with you in this course within the past few weeks, they're all should be blue. I was just taking a quick look at them, and I never seen anything that is red. Red, usually it's a negative slack. And let me explain these numbers. So these numbers in here tells you the worst negative slack. It looks at all the paths within your circuit and gives you the worst one of them. So this one here is telling you the path that you have gives you 9.1 slack. A total negative slack in here, if you have something in the red, it actually adds them up and sum this number. So you're looking for a 0 for the total negative slack. The same goes with the hold slack. The total should be 0, and this should be a positive number. Of course, there are other information that you can take a look at. For example, this one here seems to have some sort of a problem. It's telling me some of them are actually warnings. So I see no clock, and really it's telling me that I have some high severity, that you're not using. These are flip-flops and you're not using clocks with them. These are, if I go back to the RTL analysis and take a look at the schematics, these are actually the 3 flip-flops. Remember, out of 4 flip-flops, I have 3 that are not connected directly to the clock, and it's actually complaining and telling me there's no clock directly connected to it. Remember, clocks usually have their own route and their own system and connections and wires within the implemented design. Anyway, we go back to the implemented design in here. We can go to the implementation, and it will show me that here, and it actually highlighted that, like where it's like you can play around with it. Okay, so that's one way to actually take a look at those. Of course, another way is actually to go and say report timing summary. So if you click on it, and you can play around with all the different features, but anyway, I'm just going to take the default. Remember, I'm just showing you the tip of the iceberg of these, and you get to see this one, for example. I think it's very similar. Probably it adds a few information depending on the design and what you're using. And the last place you want to take a look at is actually up here. So if you take a look at the reports, you can take a look at the timing, and you can say report timing. Okay, and then you can say okay, and then we take a look at these reports. All right, so this one here is a lot more involved. This report that we generated, the timing report, so you can take a look, like you can see general information. Really what I'm looking at are timing checks. You can see the setup, and it tells me the path. And really it's showing me the actual path. It's showing me that path that we looked at like before and by hand. And you can actually go in here and say, well, show me the schematic of this path. For example, you click on here, and it's showing you that this is the path we're looking at. It's actually from the clock, and this is actually the output coming in here, going through some sort of a lookup table going in here, and that's actually the clock. The buff G is actually related to this is the input buffer, this is the buff G. These are all like the clock routing tree. Okay, but really this is the path we're looking at. So it's telling me you have one flip-flop connected, its output, it's connected to its input somehow, or through a lookup table or something like that with a QReg. Anyway, so this is telling me that this path, for example, has this particular slack. For example, for the hold, you can see it's exactly or something similar in here. It's telling me the flip-flop 0. This is the path we're looking at. So this is for a simple circuit. You can see that. Let's take a look at the more complicated project. So this project here is a lot more involved. You can see the number of lookup tables. It's like about a couple of thousand, 1,700 flip-flops. And I'm also using the BRAM. Anyway, so we open the implementation in here. You can go through the writing and everything. What I'm going to do is I'm just going to go to the report. I have to be within the implementation. I'm just going to open the implementation. Just give it a second. And in this implementation, you'll see a lot more resources are being utilized on that FPGA. And the worst negative slack, I'm just gonna take, if you remember the previous one, the worst negative slack was 9.1. This one here, I only get 0.3 nanosecond left because my system is a lot more complicated in here. And the whole time as well, the slack is really small. Still, I'm in the positive, so I'm okay. These are both zeros, so I'm still okay. And you can take a look at, I believe if you go to reports in here and you go to the timing, and I'm going to say, hey, give me the timing report or report timing in here. And I'm just going to generate that report timing. It will give me all different paths and it will highlight them on the FPGA board or on the FPGA resources that it utilized, and it will give me everything here. So take a look at that. So here I'm getting all these paths in here because my system is a lot more complicated. It's actually looked for the different path, the one that starts from flip-flop to flip-flop or an input to an output. And for example, I can click on it. I believe it should highlight it. So it's highlighting that path. If you're really interested in figuring out where is that, you can actually go to the schematics, for example, and it shows you that part. This is the schematic. This is what we care about. And you can actually log in and just see what it is. It's actually part of the CPU unit. There's a microcontroller in this design. But anyway, you can also go in here and can tell me, well, I believe some of them, let's take a look at something that doesn't involve the CPU. For example, this one in here, this is a different path. I can take a look in here and I can say, I believe, let me just see here. Yes, I think this one here, let's take a look. I think if you actually look in the diagram itself and you can, there's a place where actually it can take you the code that the code that generated this particular block. I believe it's something like show resource. There we go. I found one. I think if I click on that one here, this one, I have the code. So for example, it shows me, I think I found one. There you go. It's here. You see, it says go to source. It'll actually go to my code and it'll take me directly to that particular part that generated this. But anyway, what you really need to take a look at is the following. I have here, I'm generating, actually, there's a couple of clocks. I'm going to show you how to generate the different clocks in a separate video, but this one is 100 megahertz system clock, and this is actually a 25 megahertz, and it's showing me different ones. So the 100 megahertz, remember, it's 10 nanoseconds, so this is the amount of slack I have left. But for the 25 megahertz, I believe I have 40 nanoseconds or so, and you can see the requirement in here. These are all 10 nanoseconds. For the 25 megahertz, it's actually 40, and it's telling me the slack you have the 35. So I still have 35. So if I'm operating at a slower frequency, I'll have a lot more slack in here, and that's what this is telling me. But anyway, if you take a look at those, they're all positive numbers, and that's what I care about. So everything is fine. I'm going to take a look at the hold. Again, everything is in the positive, so I'm okay. And the timing report that we've seen in here, so when we actually opened the open implementation and we saw the timing, the short summary one, I don't think I can see it anymore in here. It usually gives you the worst version in the setup time and the hold time. As long as these are fine, everything is fine as well.